but also that's the weirdest line I've ever had to say in a movie.
We are now going to attempt to finish it in 28. Okay, we're going to start with the hyperbolic departure. And the altitude is 10.79. Raise it by 1 degree.
Don't worry, we're going to cut this all up. It's going to be great.
I just wanted to give you a snapshot of what the process of creating these videos kind of feels like. For the most part, I really don't edit these videos much. Well, kind of a little bit. Some of the errors are actually made into the videos, but for the most part, the process is basically me sitting in front of a computer and then trying to get things right, just like Matt Damon did in Martian. Okay, so I feel very much like him actually. I kind of identified with his situation, I guess, during this whole process. All right, today we're going to talk about Python data science and visualization. We're going to talk about specifically a lot of libraries that we can use to wrangle data and also kind of create very interesting plots. And there is actually there's a folder that I created. I downloaded myself as well. So here is the folder. So that's basically, there is this folder named Python data wrangling and visualization examples. And within that, I have basically 3 CSV files that we're going to work with. Nations data, we're going to work with a baby one, and then we're going to work with, unfortunately, with COVID-19 cases as well. All right, and then I have 2 examples using the nations data set, database 1 and 2. And there is NN, this is going to be using the COVID data set. And finally, baby DF will be using baby DF CSC. Okay. All right, so that's there. Now, in terms of Python environment, you know that I've been using Wing. I actually use Wing for most part. I stick with Windows machine and I use it on Windows. All right. Most recently, I wanted to do some work on my Mac, so I actually installed Wing. I've been using Wing also in my Mac machine. But what I did was actually on top of that, I went ahead and I'm also using a PyCharm, and this is the professional version of PyCharm. So I did not really want to use this during the class because it's a bit more complicated the way you get things running. But at the end, you get actually a much better environment to work with. Okay, so for complex projects, not just like what we did so far, but for complex projects, this will be a nice environment to work with compared to Wing. Wing, actually, the version we have is limited. It is the free version. There's of course a better version, which is the commercial version. But if you're going to switch to a commercial version, I will actually recommend you switch to PyCharm because it's supported by JetBrains, which basically creates also the IntelliJ. So if you're doing Java and Python programming, you can actually see it's the same kind of environment. So it's very similar in terms of how you build things and how you create large projects. So there are advantages, clearly, a professional IDE that can offer you. All right, so once we get into today's lecture, I'm going to actually come back to this and show you this again. All right, but in terms of Wing, if you want to run all these packages that I'm going to show you in Wing, you need to actually have them installed. So some of these packages that don't come directly with your Python installation, you have to go ahead and install them. For Windows, that installation is a bit less painful than it is for Mac machines. Okay, so for Mac machine, so you can actually go into, I have actually a link in one of these files. I do have a link that you can actually go and click on that link, and it will tell you how you can install it to the Wing, okay, to Wing 1. But to do that, in my Mac machine, what I did was basically I installed a different version of Python. So let me show you. So I'm actually using a version of Python that comes with a package called Anaconda. So Anaconda is like a package of libraries. So it allows me to have Python, also allows me to easily install other packages on the fly. So if I need Panda, I can install it directly. If I need a matplotlib, I can install it on the fly as well. So that's why I prefer this on my Mac machine. Right, so I recommend Anaconda for those of you who are using, especially these packages that we're going to use in this specific environment, Mac environment. All right, that's so much. So let's get to it. So for this is actually this area that I'm going to cover now. It's so wide. I'm going to only cover a certain small portion of it. Hopefully this will give you a good starting point, but nonetheless, there's so much more you should do. And you'll see throughout this chapter, I'm going to give you all kinds of links that you can go and explore more. And that will be very critical to really, sharpen your skills in data science, especially using Python. So these are some libraries that we will focus that will allow us to wrangle data, play with it, and then also do some visualizations with our data. So the first library is Pandas. It's basically a data science library for mainly visualization. Of course, it has a data type called DataFrames. It allows us to kind of access data and then modify it, with relative ease. And NumPy is a numerical library. So it allows you to have all kinds of scientific numerical analysis and also arrays of certain kind. So when we install Pandas, underneath, actually, we are actually using NumPy as well. So Pandas is not built in isolation. So it's built in on top of many of the libraries that we already have. So the NumPy will be part of Pandas. We have to install that for some of the things that we're going to do in Pandas. And then the matplotlib is a plotting library, and it was available before Pandas. Again, Pandas is based on this. And there is another library, which is a sub-library called PyPlot. It's basically all of this is plotting libraries, and Panda is actually a visualization library built on top of these plotting libraries. So later on, you'll see that some of the analysis that we will do in Seaborn later, and also in Pandas, we can actually use a matplotlib kind of plots as well. Okay, so it's kind of, all of this is not in isolation, they're all kind of interrelated somewhat. And Seaborn is a graphics library, it's visualization library, and it allows you to create all kinds of visualizations. Unlike Pandas, it's not both data wrangling and visualization, but it's more on the visualization side. So Seaborn is more on the visualization. Pandas is a combination of visualization and data wrangling. Okay. Finally, there is a network library. It allows you to do graphical analysis, like social network analysis could be one of them, or just physical network analysis, like locations of various location across various cities. Okay, so that's also another possibility of using this. So I'm going to basically cover all these libraries with examples to some extent, but at the same time give you all kinds of links that you can go and kind of dig deeper in each of these libraries. All right, let's start with Pandas. Let's just talk about it a little bit. So it's a data science library that allows us to create data structures and do data analysis. Okay, and there is the best source for each of these libraries is the library's own website, and sometimes these own user guides are not really clear. They're kind of complicated. You need more examples, and that's true for Pandas as well. But nonetheless, Pandas user guide is quite user-friendly, to be honest with you. Okay, so you can actually go to pandas.pydata.org, and then you can go look at the user guide, and you can look at visualization examples. So there are all kinds of visualization examples in that last link. Okay. NumPy is the fundamental package for computing, scientific computing. What we will focus with NumPy is, of course, it will be used underneath pandas, but at the same time, we're going to use some of its facilities like arrays it has. So we're going to use those arrays, ND arrays we call them. We're going to use them later as part of our analysis. Okay. So good thing about it is you can actually have arbitrary data types, and it basically allows NumPy to work very fast. Okay, integrate, work with databases and work with data and data analysis. PyPlot and Matplotlib. So these are two packages, one built on top of the other, and we're going to use these packages as part of our seaborne analysis and plotting analysis. Okay, so these libraries can be used standalone, so you can actually use Matplotlib and PyPlot to do certain kinds of plots, but they are limited if you use them in isolation. If you use them with seaborne, you have more options in terms of what you can do, because some of the data chart types later on we'll see will be quite useful. Okay. All right, so again, there is the link that you can go read more about Matplotlib. Now, finally, Seaborn is a visualization library, and this is based on, again, Matplotlib, and it provides high-level interface for drawing attractive and informative statistical graphics. So that's what we will use. The final thing is NetworkX. NetworkX basically allows you to create and modify graphs and networks. Okay. Again, the site has all kinds of goodies, and once again, the examples are excellent, and especially in NetworkX. You go click on that link and you'll see that all kinds of examples are given with explanations. I'll do some of them if time permits, but if not, you can go to the link and do more. All right, so let's talk about DataFrame. Now, so far we talked about data structures. Last week I talked about data dictionaries. So we have lists, tuples, sets, dictionaries, all kinds of data types. But we need also additional data types which can kind of treat it, which we can treat just like the Excel worksheet. Okay, think about Excel worksheet. When you have an Excel worksheet, you have columns and you have rows. And then you can address each of those columns with names. So for instance, if you go to Excel, right, let's get it going. Let's open a blank workbook for now. So you have columns A through, whatever, and then you have numbers that goes all the way down. Okay, so let me go ahead and open one of the files we have. All right. All right, so I'm going to go to downloads that we download. So I'm going to open our COVID data. We're going to work with this later, but let's open this up. All right, I'm going to say next. These are comma separated. I'm going to finish. This may take a while. As you remember, this data set has, I think now it says like 590,000 rows. Okay. Let's go all the way down. All right, so it's 597,000, almost 600,000 rows in this set. Okay, this is the data set we're going to work with later. Okay, so you notice now each of these columns A through M, they also have column names. Okay, and they have index. So on the left side, you can see that column row index is there as well. Okay, so let's leave it open. I don't want to close that. Let me close that one. So we need a data structure where we can actually name columns and access those columns. Some of you have done, perhaps used, let's say, table structure in Excel. The table structure does exactly the same thing, so to some extent. Okay, so let me show you quickly. I know we have a lot of data. It's not smart to work with this data set, but I'm going to give it a try. So let me select all. So I'm going to select all these values and go ahead and insert what we call a table. So insert a table. So what this does is it creates a table kind of structure. This was very fast. And then you can sort. So you can actually say, here are the names of the columns. Okay? And each of these columns are named columns. So if I want a new column, so I'm going to say a new column, I can just say this is equal to click on this, you see what happens. It will say table 1. So let me open this up. All right, so let me just finish table 1. Okay, I'm just going to hit enter for now. All right, so I'm going to go ahead. Let me expand this a little bit so you can see what's going on there. I'm going to say this is equal to, let's say, cases. Right? You see, it immediately picks up the name, cases, divided by, let's say, I'm just going to make a number. Okay, you click on this. Right, so now it's calculating all of the rows for this. So you can actually access some of these, of course, are 0. So give me a division by 0 error. But you notice I can actually use the name of these columns and do a calculation. I don't know how many of you use this in Excel, but this actually makes your formulas much better. It gives you a relational database like structure. Okay, so you have column names, just like your attributes in a relational database, and you have these rows. And the rows don't need to be unique in this setting, but nonetheless you can have the row access as well. Okay? So it's not just beautiful, but it's also useful. When you do calculations in Excel, it's always a good idea to create a table structure. Then you can go ahead and do analysis. You notice now you can also add what we call, if you go to the table design, you can actually add what is called a totals row. And this will be added all the way at the bottom. And now you can actually look at, let's say, a certain aggregate statistics here. You can actually take the cases and, let's say, sum them up. Okay, so this is the sum of all cases. Again, these numbers are not correct because these are cumulative values, but nonetheless, this is what this allows you. So you can actually use all kinds of functions here. Sum is one of them, average is one of them. So it gives you a quick way of aggregating your data just using. When you filter, let's say you filter by case types. I'm going to only filter, let's say, only get deaths. And click OK. What I'm going to do is, so let me go all the way to the bottom. Right? So if I get my total deaths, now I've eliminated the deaths. Yeah, again, this is a large data set, makes it hard to work with. All right, here we go. So now, if I take all the deaths and look at the maximum of them, because these are cumulative values, I cannot sum them up, but I can look at the max. So the max actually shows me how many people died, right? So all the cases of deaths, right? Right, and then maybe they're not cumulative. So let me look at some. I think this is more like it. Let's see. Yeah, this is too much. 1,000,007. No, that's not number of deaths. Okay. So these numbers are different. So they're cumulative. So don't believe in each of these. That's why we're going to use, our Python analysis to look at this data. But nonetheless, there is this table structure. Right. So DataFrame is very similar to that. So you can actually access each column using its name. So the DataFrame data can come from many resources. So it can be a DataFrame itself. It can come from a series. Pandas series is a one-dimensional labeled array. So, or it can be a NumPy ND array. So it's an n-dimensional array, and it can be used to construct a data frame. Two-dimensional ND array can be also used, and then finally dictionaries of one-dimensional ND arrays, lists, or series, or dictionaries of dictionaries or series can also be used to create or form data frame. Okay, so there's a function, data frame function, that we can use to take the data set and turn it into a data frame. All right. So if you want to read more about data frames, this is a good link. Just go to that link, and this is a nice article. I think it's quite long and it has some complicated examples of data frame structure. I'm going to use some of the properties of data frames, but clearly not all of them. An ND array is a NumPy array, and it's usually a fixed size array. It's a multidimensional container of items, but the key here is they are the same type and size. Okay, so It's a specific case. So clearly in Python we can have arrays of different sizes, different types, but this ND array is limited. So this actually allows you to run algorithms much faster. So if you know the type and size is a constant, so then you can actually write algorithms which will run much faster. So there is use for ND array, there is use for our list as well, okay, or frames. Okay. So for more to read about ND array, this is the link. There's a link that you can go read more about these, and you can look at all kinds of examples. So, and just like any other data structure in Python, ND array can also be accessed using slicing, indexing, right, or methods of the array. So we're going to use some of these methods of the array, so that's why I'm showing you this array structure. So for instance, you can take the array, like use the function, array function from the NumPy library. NP is standing for NumPy. When you import, you're gonna give alias to each of these packages and make sure that those aliases are constant. Don't change those aliases. If you know pandas is PD, keep it always PD. Don't change it. Okay, there is a notational standard, and let's use that standard. Okay, so we can take these list of lists and turn it into an MP array. Okay, so this is 2 by 3. Okay, and then we can actually go ahead and look at its type. It will say it's a NumPy ND array. We can take a look at its shape. We can look at the data type. You notice it's going to be integer. Okay, so it will be all constant. So it will be all integer values, all float values, all string values. Okay. The array can be indexed using, like, you can actually index it this way. You get each element of the array. Okay, just like matrices, you can actually do this. Okay, so this is the second row and third element, right? Okay. All right. So because it starts from 0. Now there are also calculation methods, and these are the ones that I'm interested in. So you can actually use ND array sum function, cumulative sum function, product, and cumulative product functions. So these are basically functions that you can take an array and run it on it and get cumulative values and so on. Okay, so we'll use some of these. That's why again, for most of this, if you go to this link, you'll see all these kinds of functions that are all available there. All right, so let's look at an example now. Let's create a data frame. So here is an example. I'm creating a data frame from this dictionary. Here's the dictionary. Right, so the dictionary has names and have ages. Okay, so the name is a list: Tom, Nick, Krish, and Jack, and age is a list which is 20, 21, 19, and 18. So what I'll do is I'm going to use this data frame function of the pandas library and take that data and turn it into a frame. And let's look at that frame. So as soon as we create that frame, this will be the index. Okay, and this will be the columns, right? So there will be 2 columns, and these will be the values. All right, let's go ahead and create this data frame and play with it a little bit. Okay, so I already have this created. So this is actually in baby DF.py. I'm going to open that up, and I don't need the whole thing. I'm just going to go ahead and just get the top part. Okay, all right, so up this point. Okay, so let me get this part. I don't want to delete it. I'm just going to put it right here. Right, let me add a new file. Okay, and then I'm going to save this in the same location. So I have to save this. I have to save it in the exact same location right here. Okay. All right. So the stop part is actually importing the pandas library, and then I have a dictionary with the data, and then I take the dictionary and turn it into a data frame, and then go ahead and print this. So let's go ahead, comment these out, right, and then go ahead and run this. So this is our data dictionary. So that small dictionary is. So what we can do is, once we have this dictionary, we can actually take a portion of it actually. So this is df. I can actually look at only one column. I can just say name. So you notice now I can actually look at only one column, right? I can look at age. So this is how I access individual column. So it makes it very easy to access a certain column. I can access a row as well. A row access is a little bit different. You just use it with a lock, all right? And then say the index. So that if you say 0, it will be the first row. You'll see that the first row, the name is Tom and age is 20. If I look at the second row, it will be Nick and 21. So this data frame allows you to access it by columns or also by indexes by rows. So by default, indexes go from 0 all the way to the last number minus 1. Okay. So you can use these default indexes, but you can also set your own index as well. You could take one attribute like name and make it an index as well. All right. Just like in keys, you can actually make it like dictionary keys and use that column for indexes as well. Okay. So you can also do calculations on this. So here are some examples. I'm going to actually get the stats. So the first one will actually get the entire data frame stats. Okay. So here are the stats. So look at the stats: count, mean, min, max, and then also the quartiles. So by default, I get all those immediately. I can also pick a column and get it is. I can use the describe function to get its own, statistics. But you notice this in this case, these two will be exactly the same because I have only one numerical column in this data set. If I had more, these two will be different, right? So this last one will be the only one column. This will be for all the columns of your data set. To show you that, and I'm going to go ahead and actually create a new column. I'm using the data frame and I'm getting the column age. And then what I do is I use a function called cumulative sum. So what it will do is it will go ahead and calculate the cumulative sum and name them as a new column called total age and create that in my data frame. So if you go through, you see what your data frame becomes now. So your data frame has 3 columns: name, age, total age, and it's already changed. So now if you go print, just look at your data frame, it will have that. So you can actually go now and access, let's say, total age. Again, total age doesn't make any sense in this setting, but nonetheless it's a column I'm calculating. Okay, so here is the total age from all the way through first to fourth element. Okay. All right, what else? I can also create baby df using a file. So let's look at this file first. So in the file, the second file, this is what I have. I'm going to play with that a little bit more because it's more complicated. I can do more. So the baby frame example, I have basically sales figure. So here are the ID numbers for my salesperson and name of the salesperson, the region, and sales, total sales for each salesperson. So what I'll do is I'm going to do some analysis. I'm going to find average sales per region. Okay, I will do that. Okay. So do all kinds of analysis using this. So I'll look at the regional averages and so on. All right, so let's do this. So this data set is in a CSV file called, what is the name of that file? BabyDF CSV. So I'm going to go ahead and read that file first and take a look at it. So let's do that first. All right, so let me get rid of these. I don't need those for now. Let me comment them out. Okay. Run this portion. All right, so this is my sales data. Index goes from 0 all the way to 19 because I have 20 rows, and these are my 3 columns: salesperson, region, and sales. The next thing I want to do is I want to go ahead and calculate the stats. So I'll go get the stats. And now I'm going to choose a column, and I'm going to also not choose a column. So let's look at the difference. So let's go ahead and run this. So you notice now if you get the stats for the entire data set, it will take anything that's numeric, ID and sales. It will do the analysis. It will give you the mean, max, and all that. Okay, so it doesn't care whether ID is not something that you need to care about in terms of statistics, but it will go ahead and do this. And then you can also go ahead and pick any column, sales column here. I'm going to describe that here. The average sales is about $179,000 and max is $218,000. Again, these numbers are generated them randomly, so they're all random, that they have no meaning. Okay. The next what we'll do is we're going to now calculate regional total sales first. I'm going to go get the total sales. So the total sales, I'll run this and you'll see that I'm going to create a new column called total sales, and that will basically get a cumulative values of all the sales. So it starts from the first value, index 1, index 0, and just creates a cumulative column for you. So it's very powerful, very useful function that you'll be using quite a bit. Okay. You can also create ranks if you want. Let's do that. I'm going to actually do rank. I'm going to say, so let's do this. Alright, so I'm going to go run this. So you'll see that it's going to find me the rank. So which one has the highest, which one is the second highest, and so on. Okay. So it's the smallest to largest. You notice it starts from the smallest value and goes all the way to the 20. This is the largest value. Okay. So we can do rank as well. Alright, so let's go back to our original. So once I have the cumulative values, what I want to is I'm going to now calculate the average sales per region. Okay. Right. And I'm going to take this and now let's take a look at what happens. So when I do this, when I go ahead and so I have the total sales. I need that. So let's go ahead and run this. Let's see what we get. So you notice now I'm doing an aggregation. Okay. So I basically create regional total sales, and now I'm doing an aggregation over region, and again I take the column sales and then create the cumulative sales. The only difference is now I'm doing a group by. So now the sales, if you notice, each region will have its own cumulative sales. Of course, it's hard to see it this way. What I need to do is I need to sort them so that you can see. I'm going to actually take and sort the region values. It's relatively simple. I'm just going to go ahead and show you what it is. So here is, you take the data frame, and then there's a function called sort values, and then you can decide what it should be. So you can say it should be by region first, and then regional total sales later, and then it says in place, so that means go ahead and change baby DF. So if you don't do in place, actually it doesn't change the baby DF, but you have to do in place so that it changes the baby DF. Okay, so let's run this now. So you notice now it will find the regional sales. You can actually see these values, east values. You see that it's a cumulative within the region. You don't have to sort to see this. It actually does it automatically. This does the exact same thing, but sorting actually allows you to see that it's actually correct. So the first value, this is the sales, this is the total sales, and this is the regional total sales. Okay, right. So you notice now, you look at another region. Let's look at the south region. You'll see that its cumulative values are starting from the first element in that region and goes through it. Okay. All right, it's very powerful. And next in this example is something that is somewhat relatively easy to do. Okay, it's basically I want to calculate count how many are in each region. I'm creating a cumulative count. I'm adding 1 to it because it starts from 0. Without 1, let's go ahead and see what happens. So what happens is they are sorted already. So now it shows me in each region how many units are there, but it starts from 0. By adding 1 to it, I'm actually getting the correct counts. So it actually gives me the correct counts. So even if this wasn't sorted, these counts will be correct. It will give you the cumulative counts on each region. So you notice this is 1 through 6 in that region, 1 through 5 in that region, and so on. Okay. So for each region, it actually gets you cumulative count. Of course, you could do ranks in the regions. You could do all kinds of functions as well. Right? It's very powerful. And then finally, here I'm going to do something much more complicated, and this will take some effort. So let's go ahead and do this first. Right? So what I'm going to do is first, alright, so let's get rid of this part first. So what I'm going to do first is, what I'm trying to do is I want to find the mean per each region, add a new column where it will have a new value for average value for each region. Okay, so I want a new column here for each region's value so that I can have the average. The problem with this is when you do the calculation, it's relatively easy. So you basically take your data frame, group by a region, and take the sales figure, and then find only you do is mean. But when you do this, you see that what you get. So you basically get a new structure which basically has a region, and for each region it has average. Okay, so you notice now I have only 4 values in this table. Now the problem is I have to take these 4 values and then assign them to these 20 values. So that kind of takes a little bit of effort because of the size. After the calculation, the size is not equal. So here, after do the calculation, their size equals. I'm actually doing a cumulative count for each row. But here I'm aggregating. So aggregating over each region. So I get an aggregate value mean. So that takes a little bit of effort. For that to work, I basically set the index to region, and then set the region average to the mean value. This way I can actually, basically what I'm doing is I'm taking the original baby DF, and I have this intermediate values that are coming from that grouping, and then I assign them to baby DF and then go ahead and reset the index. So I'm assigning them by region. So by setting index equal to region, what I'm saying is that use region to merge these two tables. Okay, and once you do that, then remove the index so that the index goes back to the original value. Now in this specific setting, just resetting the index doesn't make any difference. Even if I don't do this, it will be exactly the same index. So let me go ahead and run this, and just go ahead and run it to show you. I can now actually go ahead and take my baby DF, okay, right, and then lock an index, and I can lock it based on, let's say, west. Okay, so what it will give me is it will do a row selection and give me only the west values. Okay, so if I don't set it, so let's go ahead and not reset. You see, it's going to work exactly the same way. It will be exact same way. The reason is because in this index, in this specific setting, I do grouping only by one attribute. Okay, if you do it by more than one attribute, this becomes very important. So this resetting the index becomes more important if you have, let's say, 3 values that you do the grouping by, 3 columns. Okay, so because of that, I want to keep it. So I want to keep the structure that can apply to multiple columns as well. So if you have multiple columns, all you have to do is just list them by commas. Okay, so we'll do that example later. All right, so this is baby DF. I know even the baby DF is somewhat complicated, but this actually is what it is. So it basically combines all your Python skills and then using these additional libraries that we have. All right, so let me close all of this. Let me save. I don't want to. No, let me just save this first. Okay. All right. So let me stop here so that the videos are short. The next time I'm going to start talking about some of the additional Python functions in the next video. All right. So let's talk about some data frame functions in Pandas library. All right.